The brute force algorithm. The brute force algorithm, though not attributed to a single inventor, has its conceptual roots in the early days of the computer science during the 1950s and 1960s. It emerged as a straightforward strategy used by researchers and engineers when computers were first being developed in the institutions like Bell Labs and MIT. The method involves systematically trying all possible solutions to a problem until the correct one is found. While primitive compared to modern algorithms, brute force helped shape the development of algorithm design and complexity analysis. Today, it is still widely applied in areas such as cryptography, pattern matching, and small scale optimization problems. View of this algorithm, it applies a naive approach that explores the entire solution space without relying on heuristics or optimization. Its main strength lies in its completeness. It ensures that the correct answer will be found if it exists. This method is particularly useful in scenarios like password cracking, exhaustive search, and good for string matching, where precision is prioritized over performance.
Time complexity. The efficiency of brute force algorithm is often constrained by their exhaustive nature. For most problems, the time complexity scales factorially or exponentially with an input size such as O n factorial or O 2 to the power of n, due to the need to evaluate all possible combinations or arrangements. Although not optimized for speed, brute force algorithm offers a consistent performance model regardless of the input pattern or structure. This predictability is useful in theoretical analysis and worst-case benchmarking. It also serves as a fallback in scenarios where there is no efficient algorithm exists or where accuracy takes priority over speed.
Algorithm simulation, real-world simulation. A brute force pin cracker was simulated to demonstrate the algorithm's application. The system attempts to unlock a three-digit pin by testing every possible combination, from 000 to 999, mimicking real-world password attacks in cybersecurity. Test cases. Three pins positions in sequence were tested. Case 1, pin. 2, 3, 4, early in sequence. Case 2 pin is 500, mid sequence. Case 3 pin is 999, last in sequence. Each test record a number of attempts, time taken to find the correct pin. Result and observation. As expected, the numbers of attempts increased depending on pin's position in the sequence. Case 1 were cracked quickly, while case 3 took the longest. The simulation confirms that while brute force is simple and always succeeds, that it becomes slow as complexity increases.
Yeah. This device brute forces them, meaning goes through 000 to 9999 looking for a pin code. And once it gets it, I can fully control that jukebox like I have, like I'm the owner of it. You know, just for fun.
Given enough time, you can solve any problem this way. And while that's technically true, it's also very limited. Take our earlier example of a padlock with 1,000 possible combinations.
For it. Here it comes.
That's manageable. But now consider something more complex like Rubik's Cube. It has six faces, six colors, and the goal is to have one uniform color per face. Seems hard. Each move creates a new combination, and the total number of possible states in mind is blowing 43 quintillion possibilities. And more, I guess. That's far too many to try manually. Using brute force here is impractical. Sure, if you had unlimited time, you eventually stumbled upon the solution, but it wouldn't be efficient or elegant. Instead, you need strategy. For instance, I'll solve it just one phase of the cube using specific techniques, not by randomly turning it until something works. So, brute force means trying every possible option until you find the answer. For solution, do find a brute force solution. Why is that so? Let's try to have a look at it. I always emphasize the fact that a good developer would always try to come up with a brute force solution first and then try to optimize it. But why do I say that? That
What?
is because the brute force method would encourage
Bro, what are
you to
you
find a
talking about,
solution
man?
if that exists. Why do I mean by that? Let us take up the problem of magic square. So a magic square is a 3 by 3 grid in which you have to fill the digit from 1 to 9. Since such a way sum of all the rows, columns, and diagonals are the same. Now, how do you find about filling this? A brute force approach would be you start filling up the numbers randomly, and then you try to calculate the sums of all the rows and columns. In this case, we found the sums to be pretty different, and hence this is not the solution if you just keep by applying the brute force method. Something like this. I just took up the sum of random combination to just find the sum while applying all of the combination. You would eventually, maybe after 32,000 possibilities, you would land up the exact solution, which would be something like,
Stop it. Get some help.
in that case, the sum of all rows, columns, diagonals comes out to be 15. But we are able to arrive at the solution because of a solution to this problem exists. Let me take up the example of the problem, to which solution does not exist. So, instead of 3 times 3, or 3 by 3 magic square, these have to have 2 by 2 magic square, and I am required to fill in numbers from 1 to 4, such as the sum of all rows, columns, and diagonals are the same. No matter how many combination I try, I would never reach an answer. So this is what makes the brute force method so important. If a solution to a problem exists, we will always be able to find it using brute force method, and hence that is what make a developer favorite. So I would like to end this by saying that as a good rule of thumb, you should always try to focus on brute force method first to try to come up with a solution to the problem. You can always optimize it later. This would also ensure that you have to understood the problem statement correctly. I hope that I was able to give you some insights about the brute force algorithmic paradigms. You can find a text based.
Algorithmic strength. The brute force algorithm guarantees accuracy by exhaustively checking all possible solutions. Its simplicity makes it easy to implement and reliable for small or well defined problems. Limitations and challenges. Its main drawback is inefficiency. As the input size grows, the algorithm becomes impractically slow and resource heavy, making it unsuitable for large scale or real time applications.
So what do you exactly mean by the brute force method? The best way to understand any problem would be an example I am taking over here. Example of a padlock. You must see these kinds of padlocks in day-to-day life. So this one can be opened using 3-digit combination. This has a combination of 2, 3, 4. If you know this combination, then it is fairly simple to open it. But if you don't know this combination and you still want to open this padlock desperately, and you still can just open this padlock somehow, well, what do you do? One thing that come to your mind is, what if I try all the combinations that are possible? So I go with 000, then 001, 002, 003, and so on. You get the idea.
And eventually what would happen is you would land upon the code of 234 and this padlock would open. So what did you just do? You just exhausted all your possibilities to open the padlock, and this is exactly what is brute force method. You're deploying all the resources available to you, no matter how much the time you're trying to solve a problem. In this case, the maximum numbers of combinations that you have was 1000. Everyone, today I'll walk you through a detailed code tracing of the brute force lock cracker program. Code tracing allows us to follow the execution path of a program step by step, observing how variables change and understanding the flow of operations. This approach helps clarify exactly how the brute force pin cracking algorithm works in practice. Before we begin our trace, let's recall that our program has two methods. The main method that sets up the target pin and display results, and the brute force pin method that performs actual pin cracking. We'll trace the execution with our example target pin 234 and observe all variable values throughout the process. Now, let's trace through the brute force pin method. Step 1. Method starts with the parameter target pin is equal to 234. Step 2. Initialize loop with I is equal to 0. Step 3. First iteration. I is equal to 0. Attempt is equal to string that format is equivalent to 000. Check 000 that equals 234 is equal to false. No return. Continue loop. So step 4. Second iteration. I is equal to 1. Attempt is equal to string that format is equal to 001. Check 001 that equals 234 is equal to false. No return. Continue loop. Step 5. Third iteration. I is equal to 2. Attempt is equal to string that format is equal to 002. Check 002 that equals 234 is equal to false. No return. Continue loop. So let's skip ahead some key iterations. So step 233, iteration with I is equal to 233. I is equal to 233. Attempt is equal to string that format 233 is equal to 233. Check 233 that equals 233 is equal to false. No return. Continue loop. So step 234, iteration with I is equal to 234. Check 234 that equals 234 is equal to true. Return 234 and exit method. At this point, execution of brute force pin is complete and we return to main method with a value of 234. Let's continue to our traceback in the main method. Step 3. We receive the return value from the brute force pin and assign it to result. Result is equal to 234. In step 4, we evaluate the condition result is not equal to null. So 234 is not equal to null, evaluates to true. So step 5, since the condition is true, we execute this system.out at print line pin found plus result. So the output will be pin found 234. Thank you for watching our presentation of brute force algorithm. We hope you found the information helpful and insightful.